Doctor. My name is Reverent and I'm the face of the Rebel Galaxy Corporation. I am sitting before you today to propose the best solution to your desire. The desire to eat your tea in a whole new way, a whole new star. With my incredible team, we managed to find the cheapest and fastest star to heat the most delicious tea you'll ever drink. From 4 different systems. System A being the yellow main sequence star. System B, the red giant star. System C, the bright blue star. And finally, System D, the dim white dwarf star. Our team managed to narrow it down to one, the only one that will fill your needs. Now, physicist Leia will reveal that magic star.
Thank you, Obi-Wan Kenobi.
Well, thank you, physicist Leia, but I have some questions for you. Okay. For each system, you were given the wavelength, the radius, the distance, and the total distance, plus some extra variables regarding the spaceship. So, how did you connect all of this information in presenting the time to heat up the tea and the cost?
Alright, so I used the given variable to find the missing variables to calculate the rest, eventually giving me how long it's going to take to heat the water and the total cost. For each system. So I found the temperature, then the luminosity, losing the luminosity to find the intensity, and then finally calculating the rest. Okay, for system A, we have 887.37 seconds to heat the water. The total cost would be $5,912,918,044,000. So system B, we have 0.2185 seconds. The total cost would be $6,5,230,120,175. Sounds good. System C, we have 1.3733 seconds and $9,854,593,755. A little bit expensive, don't you think?
I think.
System D, we have 12,379.72 seconds, and the total cost would be $8,401,525,846.
Okay, this is Leah. I see that, for example, this is the most expensive, right?
So right off the bat, we can eliminate that choice.
And then this one's the one that takes the most time, right? So we eliminate that and System D. However, from System A and System B, which one is the one you recommend to Reverend Doctor as the one he could use? And because I see...
Yes, System A is the cheapest one, but System B is the fastest. Now, what I want to give Reverend Doctor is the fastest and the cheapest. And since System A isn't the fastest, I don't think that it's the most valuable choice.
Right. It is a long way, all the way to the star, right?
And so System B is only $1 more trillion than System A, right? It's not a big difference compared to the other systems.
And well, the amount of money, even though they're all big numbers, there's not a big difference between them.
Exactly. So we can choose System B, the red giant star, as the best choice for Dr. Reverend and his team.
Sounds good. Alright.
And now I'm going to elaborate more on the exact calculations I used to find the variables for System B.
For you, Dr. Reverend, to be 100% sure that this is your correct choice. So, Citizen Leia, how are you going to find how much time it's going to take to heat up the cup and the price?
Well, you see, we're given that we're going to heat up 300 grams of water, right? And we need to know the heat transfer of water in order to find the amount of time it's going to take to heat.
Right.
So the heat transfer equation is mass times the change of temperature times heat capacity.
It is.
So we have 300 times 75 degrees times 4.18 equaling to be 94,050.
Also, then we use the intensity.
Right, and we have to multiply it by the efficiency. So we have 614,834.74 times 0.70. For 70%, obviously. And that gives us 430,384.321 energy per second. Alright, so now we have energy per second. What we need to do is count just how long it's going to take, inserting it into the equation for heat transfer. So we have intensity, and we divide it by the heat energy of water.
So that would be 0.2185 seconds.
Yeah, so now we have how long it's going to take to heat the water. And we know that it costs $550,000 for each second, right? So we multiply the cost by the amount of time, and that gives us $120,175.
And then we have to add that
to the travel cost. Miss First, please turn on board. Excellent. Now we have the travel cost. Okay, so we're given the initial spaceship cost, and that's $430 million, right? Okay, so in order to find how long it's going to take and the distance from here to there.
We have to multiply times the speed of light.
Yes, we use the speed of light. But you know how speed of light is in meters per second?
We have to transfer it.
Yes, we have to convert it to months. In order to do so,
right.
we have the conversion of meter per second to light years, right? And that's 9.46 times 10 to the 15th. Okay?
Perfect.
Okay, so now we have that. In order to convert the years to months, we have to divide by 60 for the minutes, divide by 60 again for the hour, divide by 24 again for the day, then divide by 30 for the, and that gives us 663.58 months. And now, this is only for one light year.
Am I right? But it's also the time to get there and then the time you have to go and to go back.
Exactly. But since we have one light year, and we're given the distance is 6.75 light year, we have to multiply the amount of months per light year, and that gives us 4,479.17 months. But that's only the way there. We want to know the way back.
Well, we have to double that.
Yes, multiply that by 2, and that gives us 8,958.33 months in total.
That's a lot of physics there.
Yeah, we're not done. Now we have to multiply to find the cost. So we know that it's going to cost $1.1 billion per month we're going to travel, right? Since we have that many months, we multiply it by the cost per month, and that gives us a lot of money. It's going to be $9,854,163,000,000. Okay, that's how much it's going to cost to travel. And now we have to add it to the initial spaceship cost because it's already given to us. The total would be $6,005,230,000,000. But that's not all.
Not
We have the travel cost, and now we have to add it to the heating cost in order to find the complete cost. Whiskers, can you please turn the board again? Excellent. Okay, so we have the heating cost right here. We add that with the travel cost, and that gives us a total cost of $6,005,230,120,175. And that's the total cost of System B. And that's why we chose System B, because it has I know it's the second cheapest, but you know what's the perk of it?
What is it?
The fastest. And we also want the tea to be heated up fast, right?
Sadly, I was Dr. Reverent once.
And so now, we have the fastest and cheapest star.